Hello, welcome to our lesson on segment, area and perimeter of a segment. Okay, so we are going to build the concept of the area and perimeter of a segment. Okay, so what we are going to do is we are not going to solve questions. Today we are just going to build a concept, how to find the area and how to find perimeter of a segment. Okay, so what is even a segment? You know, a segment comprises of a chord and then an arc. So when you draw your circle like this, okay, and then this is my chord. Unless I have my chord AB. Alright. You see that a chord divides the circle into two, but not two equal halves. Okay, if it's a diameter, that is where it divides into two. Then we have semicircle. All right, so this is a chord. So the upper part of the chord here is what is one of the segments, and then the lower part of the chord here is also another segment. But the bigger part, so definitely because the chord does not divide the circle into two equal parts. Okay, the side that is bigger will be called the major segment, and the side that is what smaller will be called the minor segment. All right, so as we said, a segment actually comprises of a chord and then an arc. Okay, so there is a chord, there is an arc. So that is why we can see here there is a chord here. So let's say, let me shade the minor segment. So the shaded portion here is the minor segment. All right, take note of. And then the unshaded portion is the major segment, so that we can differentiate between them. Okay, so you can see what is happening here. So the segment, okay, actually consists of a chord, okay, and then an arc. What is an arc? An arc is also a portion of the circumference of the circle. All right, when I just have a portion of the circumference of a circle, then it is an arc. Okay, so this is my chord, this is my arc, this is my chord, this is my arc for the major one. Okay, so this can be a typical example of how a segment is. Okay, so we are going to look at the area of a segment, and what you should take note is that actually a segment doesn't have, let's say, a formula. Okay, unlike circumference. When I ask you what is the circumference of a circle, okay, you can actually go from 2 pi r. What is the area? Pi r squared. That is same. But a segment in reality doesn't have, let's say, a single or a formula like that. Let me go, this is the area of a segment, but we can get the area of a segment from something. All right, so what we will do is that we will look at this chord, the angle this chord sustained at the center. So when we come like that, I think we can get the area of our segment. All right, if it is the major or the minor. So we have our radius here and our radius here, and let's say we have our angle theta here. All right, so if I have an angle theta here, then you can see that, okay, you can see from here that we have triangle OAB. This is a triangle, as we all know, and then O, there is also a sector. Okay, so see, something is happening here, so that we can get, okay, let me take off this for the meantime, I'll come back to it again. So I can get let's see, here is O, here is A, so this is my chord, and then B, and then I have my angle theta here. The radius is here, the radius. What is this? We all know that this is a sector. All right, so the shaded portion of the segment is here. Okay, study it well, we are building something. So this is what? This is a sector, and we can see the sector from here. I've removed the sector portion here. Okay, so this is a triangle, and then this is a triangle here, and then this is what? Our minor segment. So you realize that the minor segment is part of the sector. All right, this minor sector here, the minor segment is part of the sector. So what we can do from here is that then we can find the area of the entire sector, and then we also know that there is also a formula for finding the area of what? Of a triangle, so that we subtract the area of a triangle. So if I find the area of a sector, and this entire thing is a sector, and I take off the triangle, let me take the triangle off. That means I subtract. What is left? The segment, the minor segment. That is this. It's so simple that the minor segment is what is left. So find the area of the sector. Okay. Find the area of the sector. Subtract the area of the triangle. And if you subtract the area of the triangle, then we are going to have the area of the minor segment here. All right. Okay. So we will look at how we will find the area of a sector, and then the area of a sector. You already know what is area of a sector from our previous lesson. We have learned that area of a sector is what? It's theta on 360 times what? Pi r square. Okay, because a sector is a portion of the area of a circle. So the angle, all right, the sector subtend at the center divided by 3 times the area of what? The area of the circle. So this is the area of a sector. So what the entire sector, this is its area. So what we have to now find is the area of the triangle. Okay, so let me remove the triangle, and then we put it there, and then we see what is going to happen. Okay, with our triangle. So we have gotten the area of the sector. What is left is the area of the triangle. All right. We learned we all know from our basic or education, area of a triangle. So even if you have learned it before, your basic GHS, you learned area of a triangle is half times the base times what? The height of the triangle. All right. So this is area of a triangle, half times base times height. Okay. So if I look at this particular triangle here, I have my center here as my theta. If I look at this particular triangle here, the base of the triangle, okay, any of the side of the triangle can be the base. The base of the triangle is determined by where your height is. So if my height is from O to O, if I draw the height from here, okay, down here, then the AB becomes my base. All right. At the same time, if I can draw my height from here, then this side becomes what? The base. I can also draw the height from here, so that this side becomes what? My base. All right. So to make it simple for us, then if you draw the height from here, as normally we see in most of our triangle, because we don't know the value of this angle, all right, that will be a little bit difficult for us. Okay. So what we have to do, let's draw our height from here. All right, and what you should take note is that the height is perpendicular to the base. Okay, so we are definitely going to have a right angle triangle form here. Okay, so our base, let's put our base down. Okay, our base is this side, OB. Our base is the length OB. Okay, so this is our base. What is left is our height. So let's say the height, let me call it as H. So we are supposed to find the height. Okay, but we have to find the height in terms of the radius. Okay, so that when we are calculating it will definitely help us to get our answer so simple. Okay, so I'm going to find the height in terms of radius. Let's see, triangle OA. So let me call here C, so that my entire here become the R. Because the R is from O to B. So the base OB is R. All right, because here is a radius. Here is a radius. Okay. So if I look at triangle OAC, it has become a right angle triangle because here is 90 degrees. The same happens to ACB. This is also a right angle, but my focus is here. I'll find the height from here. Okay, so let's see what is going to happen here. So if I want to find the height, okay, the angle here, I have my angle here. The angle, so if here is 90, then this side becomes what? The hypotenuse. So the R here becomes the hypotenuse, all right? And then my H is here, and then I have my angle here. I don't know the OC, I don't know this side. Okay, so the angle is here, it's opposite to the height. My right angle triangle is here, the 90 degrees is here. Okay, my right angle is here, so it means that this side is what? The hypotenuse. All right, so I can say that the angle is opposite to this, and this side is my hypotenuse. So sine theta, sine of the angle, is equal to H, opposite over R, hypotenuse. So if this is the case, then what will happen? I can find the value of what? H here. What will be H? Let me multiply through by R. So R will multiply sine theta. So R sine theta will be equal to H. So my H is what? R sine theta. So my H is R sine theta. So that is my H. That is my height. And I now what? My base is what? Is the R. Alright. So if I want to find the area of the triangle, then the area of the triangle, okay, which is half base times will now be equal to half. What is the base? R. What is the height? R sine theta. So R times R, that is half R squared sine theta. So the area of the triangle, okay, here becomes half R squared sine theta. Half R squared sine theta. Now we can write the area of what? The area of the minor segment. Okay. We can then say that area of a minor segment is equal to area of the minor sector minus area of the triangle. All right, so this can be our conclusion. Area of a minor segment here is equal to area of the sector, okay, minus of the minor sector. So we are talking about minor segment, so this is the minor sector. All right, so area of the minor sector, okay, minus area of the triangle. So this is the triangle. Okay, so what is the area of the minor sector? That is theta on 360 times pi r squared. Okay, minus what is the area of the triangle? That is half r squared sine theta. Half r squared sine theta. So this is what? The area of the minor segment. Let's look at the major segment. The major segment. You can see that the unshaded portion, okay, the shaded portion is the unshaded portion is the major segment. So the major segment, it can be like this. It's like this, and then the triangle is within. Then our angle is here. Okay, so this is the major segment from here. All right. Okay. So we can see that the major segment comprises of what? Of a triangle. This is the triangle. And then what is this one? This is what? A major sector. A major sector. Okay. So this is what? This is the major sector. The major sector. Okay. So what we have to do now is to we want to find the area of the major segment. The major segment comprises of a major sector and what? And a triangle. So if I want to find the area of a major segment, okay, then that will be area of the major sector, not my number, plus area of the triangle, because in the major segment, that is where we can see the major sector and then the triangle. So the triangle and the major sector is within the major segment. All right. So, and we know the area of the triangle is a half r squared sine theta. So now what we have to find is the area of what? The major sector. The major sector. So if we are going by this triangle, let's say we are going by this triangle. Okay, so if here is theta, we have to find the angle. Okay, so this is my O. Here will be 360 minus theta. So if you are finding the area of the major sector, then we find the angle the major sector subtends at the what? At the center. That is, if here is theta, if you are assuming that here is our theta, then the angle here is 360 minus this, 360 minus theta. All that we need is the angle the major sector subtends at the center. So the angle here, so if here is theta, then here will be 360 minus theta. Okay, over 360 times pi r squared. Then we add the area of what? Of the triangle, and that will give us all the area of the unshaded portion of this circle, which is the area of the major segment. All right, so what is the area of the major sector? 360 minus theta on 360 times pi r squared plus half r squared sine theta plus half r squared sine theta, where this is the area of what? The major sector plus the area of the what? Area of the triangle, all right, which is half r squared sine theta, half r squared sine theta. So this is about the area of the minor segment and then the area of the major segment. I believe this is understood. All right. So let's look at the perimeter of a segment. Perimeter of a segment. Then we bring our lesson to a close. Perimeter of a segment. We know a segment comprised of what? We have already established the fact that a segment comprised of a chord and then arc. Okay, so a segment is a chord and arc. A chord and arc, if it's measured the same thing, chord and then arc. So if I want to find the perimeter, what is the perimeter? The perimeter talks about the distance around what? Around the figure. So that will be the length of the chord plus the length of the arc. All right. So perimeter of a segment if I want to find the distance, this plus this, so we have length of the chord plus length of an arc. Okay, so length of a chord plus length of an arc, and we have just learned how to find the length of a chord. So you can visit our previous lesson to find how to find the length of a chord. All right, and then you find length of what? The length of an arc. What is the length of an arc? Length of an arc is a portion of the circumference. So the angle the arc subtends at the center, okay, divided by 360 times 2 pi r. So this is the length of what? The length of an arc. Then you add the length of the chord. Okay, you find the length of the chord, and then you are good to go to get the perimeter of a segment. The perimeter of a segment. Okay, so this is so simple. Okay, since we are talking about perimeter, let's remind ourselves a little before we bring our lesson to an end. Okay, talks about if you have a semicircle. Okay, so let's say this is my semicircle. Semicircle. How do I find a perimeter? If I want to find the perimeter of a semicircle, then I have an arc here, and this side is what? Diameter. Because we know a semicircle, okay, divide the circle into two. So the perimeter of a semicircle will be an arc, length of the arc plus the diameter. Okay, and length of an arc, that is what we have there. Theta on 360 times 2 pi r, and diameter, where diameter can be 2r. Okay, so when you are given the radius, you multiply 2 by the radius is equal to what? The diameter. All right, then let's also see if it's a, what do we call it? Okay, but we know area 2 of a semicircle, area of a circle is pi r squared. So if it's a semicircle, half of pi r squared, that will become the area. We'll just look at the perimeter, that is the arc plus the diameter, the distance around. Okay, so let's also take this a quadrant. Okay, what is a quadrant? A quarter of a circle. So if it's a quadrant, then okay, so here will be radius, here will be radius, because it's a quarter of a circle, the angle is definitely going to be 90. All right, so you have radius, and an arc. So a perimeter of a quadrant will also be r plus r plus the length of the arc. All right, length of an arc. So we have 2r plus theta on 360 times 2 pi r. That's the length of the arc, and then the theta is 90 because it's a quadrant. So even if you are not given, you should know that the angle here is what? Is 90. So the angle of a quadrant, 1/4. Okay, so 1/4 of what do we call the circumference of a circle, which is 2 pi. So 90 over 360 will be 1/4 times 2 pi r. All right. So if I want to find the area of a quadrant, 1/4 times pi r squared. Okay, 1/4 times pi r squared. So in reality, this will be 2r plus 1/4 of 2 pi r, and 2r plus 2 can go here, 1, 2 can go here, 2. So 1/2 pi r. 1/2 pi r. All right. So this will become what? This is how the perimeter of a quadrant is going to be. Okay, 2r plus 1/2 of pi r. Half of pi r. All right. So that is that. So I believe that when you are giving any question, you should be. Sometimes you can draw a diagram like this. Okay, 1/3. Okay, and then you'll be asked to find the perimeter. Radius, then the length of the arc is the same thing. Okay, so you calculate the length of the arc. And what you should know that this is the radius plus the length of the arc here. All right, so even if you are not given, if here is 90, you subtract 90 from 360, you get the angle here as what? As 270 degrees. All right, got 270 plus 90 will give me what? Will give me 360. Will give me 360. Okay, so that will be 270 over 360 times 2 pi r, and you get the length of what? Of this particular arc. The length of the arc. So mensuration is so simple. Just go through our lessons, and I believe that you'll be able to understand. Okay, make sure you go through the playlist. I always say this, to enjoy most of it, go to the playlist and then go through all the lessons that we have taught, and maths will be simple. You'll be a lover of math. I'll see you once again. Bye bye.